Hello, hello. So this video is going to be over NGrams. If you don't know what that is, I'll explain in a moment, but basically it deals with text generation. Um, and so let's start by running. So right now we're feeding it a text file of Taylor Swift lyrics. Let's run. Let me drag the output up a little bit. There we go. So ignore this. We'll get into this in a moment. Um, then, he said he didn't know why. Come running to talk about that right now. It'll be mine, and I got lost in it. Screaming, crying, was it worth it? Escaped this town for a moment of weakness, and you looked for. Basically, uh, yeah, it just generates text. It vaguely makes sense in some areas, sometimes it won't. And I can go into a little bit of detail after I show you the next generation, just so that if this isn't something, so you can see, I guess, what the end of this will be looking like if this is something that you'd be interested in. Right now, we're feeding it Shakespeare just to show you, I guess, a difference of input. Um, you could probably write a better program, or you can insert the name of the text file in CLI or something, so that you don't have to, I guess, change the code. But right now, this is just where I had it. As near the shepherd knows not his approach, when living blood doth not be the object and the witness of my heart, master person throws the body, merciful heaven or ever, as an as any end their several counsels they unbosom shall end his being thrusts against this man showed. Basically, yeah, not great. You can see Juliet is said right there. Uh, and honestly, if I wanted to make it better, there's probably a few things I could try to do. But so that's basically what the end game is looking like for this video. So if that doesn't interest you, you're good. But if it does, we're gonna go over what a n-gram is. So for starters, let me drag this over, bloop, and zoom it in. So, give me a pen, I think. Yeah. So, what is an n-gram? N pretty much stands for any number, and then gram I want to say stands for grammar. I don't know, just something. But basically, a very basic n-gram would be a bigram, where it basically would look at, let's say, the word world, and it would try to. Oh, wait, psych. So, as you saw earlier, we're going to start with that. Here is our start of sentence tag, and right here would be our end of sentence tag. Pretty much looks like HTML. Um, so, how our text generation works, it starts with one of these, and then for example, a bigram. So I said this before. Bi meaning two, and then tri means three, so on and so forth. So for a bigram, it takes it in pretty much two words. The previous word, or it deals with two words. It would deal with looking at this, and it would try to generate a following word based off of, I guess, the previous or the prefix word. So in this case, it would look at the start of sentence character, and it would be like, okay, what are words that typically start a sentence? Uh, and you can do a couple things. I pretty much randomly decide, like I get a list of starting words, and then I'll randomly pick one. So let's say hello is randomly generated. Then the bigram would shift over. So now I'd be looking at the word hello. And it'd be like, okay, statistically, what is the word that follows hello given our corpus of text as input? Um, if it's anything related to CS, it will probably have a high probability to be world that follows it. So then it keeps on going on. So I guess following world, it would predict an exclamation point. Following the exclamation point, it would predict the end of sentence. Most likely just because exclamation point is an end of sentence punctuation. Um, so that's how a bigram works. A trigram would look at the previous two words. So for example, the start of sentence and the hello to predict the world. Uh, with a short sentence like hello world, doesn't really make sense. Or, I mean, the bigram would probably work just as well in that short sentence example. Oh, I'm sorry, there would also be another, right after the end of sentence, there would be another start of sentence. These pretty much tell you when the start and end of sentences are. Um, just to, I guess, have a standard way, so you just look for this instead of having to look for a bunch of different other characters. But yeah, so basically I look for this, and let's say it predicts the word I, and then it takes this and the word I uh, into account, and it's like, oh, let's predict the word sure. And then so now it's looking at I sure, and it predicts the word do. Then sure do, and it predicts the word love. And then do love, and it predicts the word oranges. And then it would look at love oranges and predict a period. And then pretty much every end of sentence punctuation predicts a end of sentence tag. So I told you just what a bigram was and what a trigram was. So a ngram, again, like what I said, n meaning any number. So let's say you want to do a quadragram or a pentagram or a, I don't know, anything else. Pick your choice of number, and it looks that number minus one words back. So a quadragram would look at the start of sentence, hello, world, and then use that information to predict the exclamation point. With that being said, uh, I think it's time we can dive into the code. I think I've pretty much covered everything, and then we're gonna go over, I guess, more of the how instead of the. I guess this is the how, but I guess go more in depth on the how. So right now we're gonna start with the main file. Ignore my to do. There's no, so yeah, this isn't perfect. This is just something I was working on, and I finally got it to a state where I was like, you know what? I don't mind sharing this. Um, so right now, we take a buffered reader and it reads in the file, and then we go line by line and then append each line to a string builder, uh, adding a or new line character at the end of each line because uh, I guess it helps us get the format for Taylor Swift songs where it'd be like more stanzas, or is stanzas more of a poem thing? Basically, it helps with the spacing instead of just making it a block of text. It will try to also kind of look similar to it. Versus, so yeah. Also, with the Shakespeare one, there's a big old license statement at the top. So occasionally you will get like Project Gutenberg, or you know just complete like this electronic version of blah blah blah, and it's like, oh. But then eventually it'll dive into complete works of William Shakespeare. Oh wait, sorry, that's still the see. Yeah, it's quite a long statement. And there we go. And then it starts with his actual stuff. Luckily, he has so much of his actual work that that license thing rarely does appear. If you cared enough, you could just delete it. Sorry, let's go back. So we go line by line until we reach num of lines. So I know right now that's 1,000. On realistic, or buffered reader can read, I'm pretty sure, file of any size. It's a buffered reader, so it doesn't take the whole file into memory all at once. But we are taking it all into the string builder so that we can pass it to our ngram class. Uh, well, so we can process the chunk, and by processing it, we throw it to our ngram class for pre-processing and to build an ngram model. And so let me shrink this down, and then hopefully you can see the font size. Let's try and increase it just in case. View, increase font. Did that change? I hope it did. So yeah, as we were saying, it goes through, pretty much goes up to the number of lines, which right now is set at 1,000. Fills it, the string builder full of that, and then sends it off for processing before making it, empty again. This is just so we don't have the entire works of Shakespeare all in a single string, because I believe that would be defeating the point of the buffered reader if we just had it all in memory anyways. Uh, yeah, and then so process chunk is just a little helper function I made where it pre-processes the text and then builds an ngram model, and then we no longer need the text. And then we're just going to go ahead. I'll go into what these functions do in a second, but after that, if ngram is not equal to null, then which to be honest, yeah, shouldn't be. Uh, I think that's just some old code I left there from, I just went about it a different way at first. But if it's not equal to null, then I generate and I give the number of words I want to generate. Right now it's 200. And if I want it to smooth, and we'll go over that in a moment as well. Otherwise, error ngram null. This, honestly, if it reaches here, I have no idea how. So let's go over the star of the show. So here's our ngram. This is unused. I was just originally going to make our array of end of sentence characters and then loop over and see if, like, oh, if you spot any of these, throw a end of sentence thing character after it. But besides the point. So n, here's the n and ngram. If it's 3, it's a trigram. 2, it's a bigram. So on and so forth. Frequencies, let's go to our frequency class. This holds a unigram. Uh, Now, you're probably, so it deals with however many words is the prefix. So a unigram deals with one word. How's it supposed to predict anything? It doesn't really. A unigram is more, I guess, dealing with the vocabulary itself. So I guess bringing this back. Let's say there was, I also love, ignore the capital L there, mango. Boom. So for example, the unigram would just count how, like, all the occurrences of each word. So there would be 2 I's, 2 loves, and then everything else would be just one, like one hello, one world, one exclamation point, stuff like that. That's just to help get our probabilities. Um, then the ngram deals with the actual, if it's a trigram, it'll get 2 words in here and then point to a, or no, it'll get 3, I believe. Actually, sorry. The reason it's called ngram, I believe, is because we will get multiple of them because we'll hold the prefixes as well as the actual word we point to, or the prefixes and the occurrences, and then we'll. Okay, I'll go over that in a second. It'll make more sense. I'm trying to explain it too early. So let's start off. I tried to order these in the order we use them. So we do pre-processing. That is adding the start of sentence and end of sentence characters to the strings. So it gets passed in a string, and then it uh, splits that string. It does a, I believe it's called a look around, where it pretty much uses regex. It looks if there is a end of sentence character, and if there is, then it splits it without consuming it. So if you were to do a normal split and then split it by period, exclamation point, question mark, it would consume that character as well, and then then split. But we do want it to be able to predict, like, oh, there should be an exclamation point after this word, or there should be a period, or stuff like that. A question mark, for example. So punctuation is also treated like its own individual word. Uh, then we tokenize the sentence. So after it splits it like that, and so it keeps on the, I guess, the left side of the split. So if it were like, hello world, how are you? Then the exclamation point goes with this split, and then the question mark goes with this split. Uh, Eat that. Then tokenized sentence, we just erase that stream, sentences, and then we map each sentence to literally just include a start of sentence tag with no space in before, but a space after, and then the sentence as lowercase. That way we don't have to worry about, I guess, dealing with punctuation. You could try to do that if you wanted to, but I just like not worrying about it. And then the end of sentence tag. And honestly, you can deal with that, I guess, after you generate your text. You can find all end of sentence and then capitalize the letter of the first word after. And then we return another string array of these sentences, and then we join it into a single sentence and return that. Then that is typically passed into build ngram model. So that takes in a single string of processed text. Then we use a pattern. So this is just regex as well, where this is a word, I believe. It gets any word. Um, the plus, I believe, makes it where it's has to be one or more, I believe. So it's looking for a word. I honestly don't think the plus actually matters in this case, but it works, so I'm not going to touch it. Or it looks for any punctuation. By any punctuation, in this case, we're not including hyphens just because hyphenated words I think I'm counting as one word. And then also it looks for end of sentence, start of sentence, and new line characters. You have to double escape them, by the way. So this would normally just be a /w, but since it's like in a Java string, we have to escape it. But I'm pretty sure regex looks for like a /w/this for the special characters, like that meaning a word. Then we have a matcher and then give it the process text, or give it the pattern and then tell it to match based off the process text. Then we go have a word array list, and then we okay, good. Pretty much add all the words that basically this is just an advanced split, and honestly, I might be able to do a split based off this. I just remember wrote it out in regex, and I tried just copy pasting the regex into the split array or split here, and then I just gave myself plenty of headaches trying to get that to work. And so I was like, I'm pretty sure there's a regex thing in Java, so that's what I ended up going with. But you can probably use split if you know how to work it right. Then we have a for loop. So here we go. We have we copy. Oh, sorry. Um, so yeah, sorry. All the words become tokens. Uh, and then we go through all the tokens or all the words, and we pretty much copy the array. So I guess, how do I say this? From everything, so here's the array tokens that we're copying from I to I plus n being, of course, the bigram, trigram, whatnot. Uh, so let me bring my thing back over here. Basically, if it's a bigram, it'll copy these two words. Okay, so actually it wasn't that hard to explain. Trigram, it'll copy these two or three words, so it'll copy from start to world. Let me get rid of that. And then so that'll be in here. Then the ngram key is all of those words combined with a space separating them, because that is an array, and it's combined into just a string. Then we update the ngram counter, so we go to our frequencies, which, remember, it just stores unigrams and ngram. And then we put the ngram key, and then you do a getter default, and you look for if the ngram key is already there. If it is, you add 1 to it. If it's not, you default to 0, but then you add 1 anyway, so it'll be just 1. And then you update your unigram counts to where you go through every uh, word and you increase the unigram same way. If you can find it, then awesome. Otherwise, 0 and then +1. And then we return frequency. I don't think we use frequency anywhere. That's also something I left from just old time's sake. Uh, okay, but then, so that's all our processing does, I guess, like our preprocess or process chunks. Ngram probability here finds the probability based off of a prefix you give it. So basically, again, bring this over. The prefix for a trigram would be these two words, and the word it's trying to find the probability of would be world. So it'd be, what's the probability that the next word should be world, given that the previous two words were a start of sentence and a hello, or a, sure and do, what's the probability that love, or do and love, probability that orange is next. I guess. And then Boolean for smoothing. So we'll get to that in this function. So here you have your ngram key, which is pretty much the prefix plus the word. So that would be, in this case, start of sentence, hello world. The prefix by itself is just start of sentence and hello. Oh, there we go. Yeah, so prefix key is just the prefix combined with spaces in between. The ngram key is combined with spaces in between, and then also the word at the end. Uh, and then yeah, you're trying to see if these have either existed before, and if they haven't, give them 0. So this is just Laplace smoothing, Laplace, where basically it's really easy. You just add 1 to the count, and then you take the you put it over the prefix size plus the vocab size. Vocab we get from the unigram.size. Turn. Oh yeah, so yeah, you just take basically how many times the ngram has occurred. You add 1 to it, and then you take or you divide that by the prefix count over vocab or plus vocab size. Basically, how much or what's the probability that the whole sentence or I guess chunk is generated based off the prefix? So hello world based off of hello, or divided by I guess the count of hello plus vocab size to get the probability. Otherwise, if there is no smoothing, you do not add the 1 or vocab size, you just divide the ngram count by the prefix count. The Laplace smoothing, you pretty much do that because if for some reason there's a 0% chance, 0 probability, um, I guess it's mostly, from what I've seen, if your text or corpus is in a weird or formatted incorrectly. Basically, if there's like an end of file or something or end of line based on how you're doing it. Because right now, so my to dos in my main, right now I take it by lines, but lines don't necessarily mean sentences. So I have a little to do list to instead of going like line by line, go sentence by sentence. And this is because, for example, uh, I guess he does it good here. But basically, if a line were to end here, but the sentence, I guess, were to end here, these last two bits would be kind of chopped off. That is why we add everything to a string to help, I guess, mitigate that. But for the example here, I guess, if it ends the file or ends the whole chunk as it, like, let's say you hit your number of lines at 1,000 or number of sentences, and well, I guess number of lines ends at 1,000 in the middle of a sentence, then it could end in a way where it's like it's the only time a word is said. And so basically, if it ever gets to that word in text generation, it is like there's no probable chance that any other word is generated after this. In which case, you add Laplace smoothing to make it where each word would be, I guess, equally probable. But it also doesn't mess it up for normal stuff where, let's say, hello world, world has a high percent chance. You just add one to the number of counts that world has appeared after hello. It does make everything else that had a 0 probability have a small chance of being appearing, but that's also nice just because uh, if you just want to take like the top 3 most probable words, um, then that will, I guess, make it to where you won't have two 0% chances. I guess everything will have some percent chance of being generated. Um, kind of finally, this is the last really major function, generate text, to actually generate the text. So you take in if there's Laplace smoothing or not, and how many words you want. So then we start off with a string builder called generated text, and we start off with the initial start sentence tag. Uh, and honestly, I was just lazy, and that's why every time we generate stuff, it starts with this. I do later on make it where it should go through and delete all that, but I think, I mean, obviously it appears, so there's some bug here, but it hasn't really messed with anything. It just, the user sees it instead of them being like invisible. But sorry, moving on. We have a context here, which is pretty much in a trigram, it would be the start of sentence and hello, and then you'd be trying to predict the word world. But yeah, the context I believe is just not I believe is just the preceding I guess words, the prefix as we called earlier. Then you go through how many words you want to generate. You have a hash map of candidates, and then you go through here and you for each I guess ngram in your frequency set of ngrams, you join it all together, or you join your context together and see if the ngram starts with that. Uh, and then you set your string of next word equal to, you split your ngram and then you get the final word of it. So if you read your corpus and you got, hello world, uh, then you would be like looking at world right now, and then you would get the probability of um, worlds, which, it's because it's the last word in the context. And then you would context to the right. Oh, uh, huh. I'm gonna come back to this. Think on that for a bit. I don't know if that's supposed to be a 0, because it would be creating or it's just a new or string array, to array string 0. Should that be for this purpose? I think it's just getting the context and then just turning it to a string array, which should, the context is just the prefix. I don't know why the 0 is there. I guess that's what's confusing me. Uh, instead of something like, I guess, let's try it like this. String, and then new. Does that work? Okay. That also may have been something I just copy pasted over from my previous edition. We will run at the end again, so if that breaks, then I'll just come back and fix it. Uh, so, and then yeah, sorry. Then candidates dot put, you add the next word plus the probability that the next word, I guess, the probability of it existing. And then you pass all the candidates, so pretty much every possible. So it's like hello John, hello world, hello human. You'd pass those candidates into a goofy function, select random word. Uh, I do have it. We can just look at it if you want, just so that if you're writing along, you can write this. But basically, yeah, it just selects a random word. Random is, of course, just the random class at the top of this. And we just use dot, next or get next float or whatever. Oh, did I scroll too far? Lost myself. There we go. And then if we reach the end token, start a new sentence. This, I was running into a bug, and that's why I have this. There's probably a better way to do this as well. But so you basically, if the next generated word is end of sentence, typically if there's a period, then you append to the generated text, you append a space, end of sentence, and then a space and a start of sentence. Uh, and then, sorry, I was thinking a little bit about why I included the spaces instead of no spaces, but then I remembered I'm pretty sure back here we split by spaces anyway, so I don't think they matter. Well, I think they do, because if we don't have the spaces, then it would get the end of sentence and start of sentence all as one, and would not be able to, I guess, discern that they're supposed to be separate characters. And then we set the context, sorry, to just a normal or a start of sentence just by itself. Uh, this also probably should be where it does include some of the previous sentence. I think I was running into weird issues where it would just keep spamming a start of sentence character, which is, again, something I have to look into. But so far, this is just, I was able to write this by completely clearing the context and replacing it with just a single start of sentence. It's acting as pretty much the start of the text generation as a whole. It can't use any information from the end of the previous sentence, but honestly, that's probably a good thing, just because you do want your sentences to be varied. And let's say if you're using a trigram or a quadrigram or a higher level gram with like Taylor Swift lyrics, you could end up getting, I guess, the entirety of a song if the song was unique enough and you generated one of the words from it. It could just be going, like now we got bad blood, and just like continue off of that, because I don't know if another song in her thing has bad blood, and then it'd be getting bad blood, and let's say from the previous sentence, and like, oh well, then probability or the probability of generating the next sentence or verse in this bad blood song would be extremely high, and if she doesn't say bad blood in any other song, then there's really no chance for it to escape, as long as there's bad blood in the context. So here we just clear the context and set it to a start of sentence character. That way you can kind of get new sentences every time. Realistically, they may not flow as well, uh, but I am very happy, I guess, with the sentence by sentence. Like, if as long as each sentence kind of makes sense, I'm happy. And sorry, did spend a little bit of time on that. So append the word and update the context. We then just add the next word to the generated text and then update the context. We remove the first one if it is bigger than the n, so or bigger than or equal to. So trigram. Basically, after we append it, it'd be like start of sentence character, hello world, and then here we are clipping off the start of sentence character, so it'd just be hello world. And then we add the next word to the context. And then, oh, sorry, then format generated text. So here we go through and every start of sentence character, we make nothing, every end of sentence character, nothing. If there is because since we do treat punctuation as their own words, it does put like, it would put a space, apostrophe. So like, in the word your, like or yeah, YOU apostrophe RE. Uh, or I guess any junction word. I forgot. I don't think conjunction is the right word, but whatever. Uh, it would pretty much be like, YOU space apostrophe space RE, which kind of looked weird. So we do remove the spaces around that. Same with all this, it would also be at the end of sentence, it'd be space, exclamation point or space period. So we do remove that and then replace it with just pretty much whatever punctuation it was. Same with a comma as well. And this, the round parentheses are a capture group, which it lets us do the $1 to pretty much say whatever was captured here, put it here, with no spaces around it. And then for quotations, for certain corpuses I was using, there would be, quotes. If you're using a book, especially, and someone's talking. Um, and so here, this lets, it'll take the spaces away from that, but, doesn't treat it the same as the other ones, I guess. And then it returns that. So that, this should be ready to print. And then here's the select random word. If you want to pause the video here, look at this, write it down or whatnot, but it just takes in a random word and then worst case scenario puts a end of sentence character, which I believe this actually was the origin of my bug, but I think I forgot to change some of the previous stuff where I was actually originally returning a start of sentence character, but then it ran into something where it was like, there's no select random word, which probably is honestly an error with this. Uh, but ignore that for now. And it would just spam start of sentence characters, and that's not good. But if we do an end of sentence character, then it goes back and then generates a start of sentence character space. It pretty much refreshes everything. Uh, but yeah, so that is currently all that there is. This literally any text file, and then you swap out the file path here um, with it. So our Taylor Swift file, we can go back here and copy content root, and then we paste it, and then boom. Oh, sorry. So at the top here, you do have your ngram. So let me show that real quick. So here's what we just generated. This is trigram stuff. Starts with Johnson and then new line. That I left I all these days. Tell me why. Everything will be remembered. Elevator. So sorry. This is it's good. It's just not perfect. Corpus of text. But remember elevator buttons and morning air strangers silence. Makes me want to take our love and tear it all behind me. Up and sent, blah, 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 blah. Basically, this is a trigram. So typically, there is a sweet spot. So for a bigram, for example, if you thought that didn't make sense, bigrams, it only makes sense, with the previous word. So standing alone, found Wonderland, uh, shake it. So since each thing is treated as a word, a bigram only really looks at the apostrophe and then it predicts the T. So I guess in the word like won't, like WON apostrophe T, it is like, oh yeah, there's a chance that after an apostrophe that there's just a T, but in a trigram, it would look at the preceding word as well. So sorry, in a bigram right now, this is broken. You could go through and maybe make a special exception or something, but right now I don't. So right now it says also it's and then itiv, keyed your car, keep your hair undone, and I figured out baby are young things. It should be more thing when I threw at the lucky one. Basically, yeah, as you can tell, like lucky one. Okay, that makes sense. The lucky, yeah, at the sure, threw at. Each one makes sense, I guess, when you just look at the context. But overall, the sentences can be a little bit jumbled and weird. We saw the trigram previously. That'll look, at it would be like through at the like this sentence honestly makes great sense for it being a bigram. Uh, at the lucky one. Like, those all make sense. Quadrigram, you can keep increasing. This does become more computationally intensive as you do it, but there's also different problems so that the higher you make this, the more likely it is to just spit back out the exact, corpus. So like if you were like, oh, taking the past 6 words to compute the 7th word, then it would probably be looking at like the whole line in a song, and then it'd be like, well, there's only really one occurrence of that line. So I'm going to predict that the next word would probably be the start of the next line of that song. For example, I don't know if Taylor Swift has a Christmas album, but I did look through the corpus and I found, it was like Last Christmas. Uh, but yeah, so Last Christmas, I Gave You My Heart. That's classic. But the riding in your truck and all I see is someone I don't have a reason to go. Oh no. That more or less, riding in your truck and all I see is like nice. Then you have all I see is someone, see is someone, uh, see, yeah, okay, see is someone is someone I don't. I don't know. You get it. You get it. So I guess wake up and smell the breakup. Ooh, that's probably something she actually said. Uh, Fix my heart, put on my makeup. It even Johnson. So I guess there's somewhere where there's like a double space and then the word Johnson, and then it just loves to drop that in. I'm not really big into Taylor Swift lore. It was just something I was like, oh, that'd be fun. Uh, and I guess to show you, let's drop in I don't know what a 7 gram would be. Septagram? But let's see if I can show you. Oh, wow. Mandolin? Oh, yeah, mandolin. Got a car, got a scar. Like everyone, he's got a few, but everyone loves that mandolin. So, yeah, again, not a huge Taylor. Oh, well, I guess let's do this. Got a car, got a scar. We're going to copy paste that and search for it. Like everyone, he's got a few, but okay, yeah. So, yeah, as you can see, it's like pretty much telling you exactly uh, what there is here. Tip jars, yeah. He's got his heart on his sleeve. Okay, so yeah, he is. It's pretty much exactly like so. The higher you, it doesn't make it, I guess, better. Well, it kind of does because it makes more sense, but it makes more sense because it is in fact just copy pasting it from the course or the corpus or the source material, pretty much. So there is a sweet spot where it makes enough sense, but also is different than the source material. And I found that 3 and 4 are pretty good for that. Uh, But yeah, and it's just been, a fun little side project I've been working on. You can, play with it a little bit. Throw it in, the Lord of the Rings.txt, and you can, generate some fan fiction or whatnot. Uh, or maybe if you're writing a game, you can maybe have like an NPC, that uses an Ngram, and it'll probably be, jumbled sometimes if their text isn't important and it's just like some random guy on the street you want to talk to, and he's like, "Oh, good Morrow orange juice," and they're like, "What?" But it could be fun. Anyways, thanks for watching.